We go on to question 13. Question 13 says the following: how many whole numbers from 1 to 500 are divisible by 3 and 5? Now, if a number is divisible by 3 as well as 5, then it has to be divisible by 15. So because 3 and 5 have got no common factors, so it has to be divisible by 15. So the question is now, how many numbers are divisible by 15? How many in the set from 1 to up to 500 are divisible by 15, or you can say are multiples of 15? So really, that is the question. Okay, so you can start with 15, and you can go to 30 and 45. Question is, where does it end? And how many are there? Okay, the way to do that is actually to see how many 15s there are in 500. And how many 15s are there in 500? Just division. So you can divide, but I like to convert to fractions because 500 divided by 15 is the same as 500 over 15. And straight away, you can cancel the 5s. And you have 100 over 3. And that is 33. And the third. All right, so it means that there are 33 15s in this. Let's look at the last 15. 15 times 33. You check the thing out, you'll see it's 495. So it goes right up to 495. And of course, there are no further multiples because it finishes off at 500. The next multiple will be more than 500. So how many are there? Answer is 33. Okay. There's not much here, but the only useful thing is, instead of doing long division, sometimes it might just be much easier to convert to a fraction, and then you can see what the answer is straight away. Right, let's get on to the next problem. First, let's just check to see whether our answer is... Oh, okay, I didn't put 500 over 15, but this answer is still 33. Okay, so I found a better way of getting to 33. Let's get on to the next problem. We go to question 14. Now here it says Tom and Dick together weigh 135 kilograms. Okay, that means if you, let's say that Tom's weight is T and Dick's weight is D. That means when you add the two weights, you get 135. Okay, that takes care of the first fact. The next one is Tom and Harry together weigh 140. Weigh 140. Right, so we've taken care of that. Now Dick and Harry together they weigh 125. And the question is, what is Harry's weight? Now, you might say, oh, you've got three unknowns or three equations. It's not fair to ask us in the junior competition to ask us to solve three equations with three unknowns. We don't know. We were never taught about that. But, in mathematics, you can think of quick ways of solving problems. Like, yeah, if you observe, you'll see I got two T's, I got two D's, and two H's. Right. So why don't we add on both sides, and you have two T's and two D's and two H's, and when you add all this, you got 260 plus 140, that's 400. All right, so D plus T plus D plus H, and divide right through by 2 is 200. So you know the sums of the sum of the weight of all three people together. You wanted Harry, so to get Harry, you take away T plus D, but T plus D is 135. See? So that tells you that Harry is 200 minus 135, which is 65. So although it looks as if we got three equations, three unknowns, there is, just by looking at it, you can solve it quite quickly, because you can work out the sum of the whole three, and therefore we know the sums of two of them, so therefore you can work out the sum, the remaining one. And like that, you can work out the ages of each, the weights of each one of these people. All right. Now there is another way of doing this thing. This requires pure logic. You see, I've got Tom and Dick together. Tom and Dick, they weigh 300. And then you got Tom and Harry. Let's just look at this. Tom and Harry. I'm going to put this here. They together weigh 140. Now, if Tom and Harry weigh 140 and Tom and Dick weigh 135, then it's quite clear that it is Harry that is heavier than Dick by 5 kilograms, because Tom is in both of them. Right. So Harry is contributing to 140 and Dick is contributing to 135, and Harry is 5 kilograms heavier than Dick. Harry is 5 kgs heavier than Dick. From these two statements. But now you know here, Dick and Harry together weigh 125. So you've got two numbers, H and D. When you add them, you get 125, and one of them is 5 more than the other. Now, common sense will tell you it has to be, they add up to 125, so, and one is 5 more than the other, one has to be 60, and the other has to be 65. Right? Harry is 5 more than the other, so that gives you Harry's weight, 65. It's the same as this. The pure logic, without having to look at equations. Right? So that's a nice way of solving that problem. Okay, let's just get on to the next one. Okay, so here we did it the first way, without doing the logical way. This will come to the same answer. Okay. Well, so let's go to question 15. The question 15 says 36 identical cubes are used to build a rectangular prism. So you can see this picture is quite clear here, because you've got 3, 6, 9, 12. So you've got 12 at the top. So you've got 12 in each of these 3 layers. Right? They're all repeated. So that's how you get 36. 312 to 36. All right. Now they say one such example is shown. How many other rectangular prisms with different dimensions can be made using all 36 cubes? All right. Now, so how did we get 36? 36 is really length, there's length times breadth times height. So 4 times 3 times 3 is how you get to 36. 4 times 9. All right. So you want to know how many different rectangular prisms. This is not called a cube, right? Just observe. This is not called a cube. A cube will have all the sides equal. Yeah, you got the sides are different. Two of them are the same, 3, 3, and 3, but the other one is different. So it's called a rectangular prism. So rectangular prisms, you need to have three numbers which add up to 30, multiply to 36. And that way you can construct your cubes. You'll have your length and breadth and your height. Okay, so we have to find out how many ways can you take three numbers and get to 36. So let's do it the easiest way, 1 times 1 times 36. All right. There you go, 2 ones. Let's make it 1 times 2 times 18. That's another way. Okay, so you look at the factors of 36. You get 1 times 36. And you put 1 here. 2 times 18. 3 times 12. 4 times 9. All these are factors of 36. But 5 is not a factor of 36, but 6 is. 6 times 6. Okay, so that takes care of all those ones. Beyond this, now you'll get the same answers here. All right, now let's suppose now there's no 1. So you have 2 times 18. Now let's factorize 18. You get 2 times 9. All right, 18 is 2 times 9. You can also have 3 times 6. I think it stops there. So those are the two with that. And of course, if you have 3 times 12, now you're not allowed to put 2s and 1s. That is why I didn't put any 1s here. I just put them in increasing order. If you put 1s, you'll get repeated. You'll repeat some of those things. We don't want to repeat. And 3, now you can't put 2 or 3, 1 or 2. Start with 3. 3 times 3 is 9, 4. But that's the same as this. Okay. And they say how many such examples, how many other rectangular prisms. So in other words, you don't want to repeat this now. So that gives you the number of rectangular prisms, 1, 2, 3, 4, 5, 6, 7. So the answer is there are 7 such rectangular prisms. And these are the dimensions of that. And you can use that to calculate to construct a cube like this, right? Which has got 36 cubes altogether, using the same cubes. Okay, so that takes care of that problem. And so the answer is 7. Okay, so it's exactly the same thing that I had done there. Let me now move on to the next problem. So we now move on to question 16. Question 16 says that Josh and Tabo are at the same starting point on a long straight road. So let's draw the road. And we see that they're both at the same starting point. So J and T together here. Now Josh starts driving at a constant speed of 70 kilometers per hour. So Josh takes off. Right? Turbo is still standing, but 1 hour later, turbo starts. So Josh has moved up to a certain point, and 1 hour later, turbo travels. Now Josh travels at 70 k's. Josh starts driving at a constant speed of 70 k's, and turbo, he travels at 84 k's, 84 kilometers per hour. So turbo is traveling faster. So sooner or later, he's going to catch up with Josh. Right. Now the question is, how many hours will it take for turbo to catch up with Josh? Okay, that is what I said. They're going to catch up. Now, let's see now. Josh is traveling at 84 kilometers per hour. So when turbo starts, he's already traveled 70 k's. So turbo is here. Turbo is 70 k's ahead. And then this guy starts. Now he's traveling at 70 k's, 70 kilometers in 1 hour. And this guy travels at 84 kilometers in 1 hour. Okay, so what does this mean? It means he's traveling at 14 kilometers per hour more faster than Josh. So in other words, in 1 hour, Josh is 14 minutes closer, 14 kilometers closer to turbo. Okay, so you still got another 56 kilometers more to catch up. Right. So you can see now how long will it take to cover 70? It has to be 70. How many 14s are there in 70? Each hour he gets 14 kilometers closer. So after how long will he catch up? So it's 14. 70 divided by 14. 7 goes into 10 times, 7 goes 2 times. 10 divided by 2 is 5. So the answer is 5 hours. Now remember, this is hours because we are saying in 1 hour, he'll be 14 kilometers closer. So it'll take him in 5 hours, it'll be 5 times 14. He'll catch up that distance. Okay, so that is using pure logic. You can solve that problem, but you could have solved it just using mathematics, like this, and you can take your pick. Right? I like both methods. So you got Josh is here, and Tabo is here. He's traveled 1 hour extra, and they meet. They meet after. Okay, suppose they meet T hours after Josh takes off. Now Josh also travels for T hours. So when they meet, it's the meeting point. Josh would have traveled T plus 1 hours, and Tabo would have traveled only 3 hours because he had a 1 hour lead. So when they meet, they both would have traveled the same distance. So this is the time. There are two different times, but this guy is traveling at this fellow is a slow coach. He's traveling at 70 kilometers per hour. So they meet after 70 times t, and Josh would have traveled no, actually, sorry. Uh, Josh travels less time. Thabo has got more time because he had a 1 hour lead. Right, so Thabo had more time to travel. So his speed was 70. So Thabo would have covered 70 into t plus 1. That's the distance Thabo would have covered. And Josh would have taken only t hours, but he's traveling at faster speed. So you get this, and then you'll see 70t plus 70 equals 84t. Bring all the t's to one side. 84t minus 70t is 14t. It's equal to 70. Then we are right there. So t equals 5. So after 5 hours, they meet. Now this is using mathematics, you see. Here you are using logic. Okay, so in both cases, you get to the same answer. Okay, so let's just clear this and see. Whether I got 5 hours. Okay. Well, I used some argument. I think I used one of those two arguments, and I came to 5 hours. But now I've given you two different methods of doing it, and there's no equation here, just the logical solution. So you can use the equations also, and you can solve the problem. Okay, so we're going to question 7. Now, there are only red and blue marbles in a jar. All right, so you got in a jar, you got red and blue marbles. So let's just draw the jar. So you got blue marbles and red marbles. You also have red marbles. They're all mixed up. Okay, but we don't know how many there are. Okay, at the beginning, the ratio of the red to blue marbles is 4/3. Okay, so let's say we don't know how many there are in the beginnings, but you can say, suppose there are okay, I don't want to fill this thing up. Suppose there are so many red marbles. In the jar. And the ratio is 4:3. So in other words, we can say, we saw this before, we can say that there are 4x and 3x marbles because it's going to be one of these equivalent fractions. So we can say it's not, then we can't say there are 4 marbles, but there will be 4x red marbles. Red to blue is 4:3, and therefore there will be 3x blue marbles. This is in the beginning. Why I say in the beginning? Because something happens there. If you read the rest of the story, then one blue marble is then removed and replaced with a red marble. Okay, so you have the blue marble, one blue marble is removed. So now you have 3x minus 1 blue marbles, and it's replaced with a red marble, so the red marbles increase by 1. Right. Now this changes the ratio of red to blue to 3:2. So red to blue will be 4x plus 1 over 3x minus 1. And the ratio now, red to blue, is now 3/2. And there you have it, you have an equation. And the new ratio is on the one hand, that over that, because these are the two new numbers, but you are told that this ratio changes to 3/2. So you can solve for this, cross multiply 8x plus 2, multiply this by, cross multiply 3 times 3x minus 1, and then I'll bring all the x's to this side. 9x minus 8x is x, and 2 plus 3 is 5. Okay, so you have x is equal to 5. Now they asked you how many red marbles were there originally in the jar. So in the beginning, you had 4x red marbles. We just said x is equal to 5. So the answer is 20, because we calculated x. So yeah, so originally there were 20 marbles, and here 5 times 3 is 15. You had 20 and 15. So that's what happened. You got 20 and 15 blue marbles. Yeah, red and blue. Then the one blue marble was removed. So 15 became 14, you see. And this was increased to by 1. So now you come 21 over 14. And you can see 7 goes into both of them, and you get 3/2. Right. So it's so nice. This mathematics can help you to solve the problem without having to guess the answers. See, some people will try to guess now how many red marbles, how many blue marbles, and so on. But you just have to put an X there somewhere, get an equation, and solve. That's the power of mathematics. Okay. All right. So we said the answer was 20. So I worked out. There it is. 4x. It's the same. It's exactly the same thing that I did. Okay. So there are 20 red marbles in the beginning. So let's now get on to the next problem, which is go to question 18. Question 18 starts off by saying the surface area of a large cube R. Now it's a cube, so all the sides are equal. Okay, the surface area is 464. Let me just draw this cube. So you got squares right throughout. Okay, so all the sides are all the same because they're all equal squares. So let's call this side x, yeah? Okay, they say the surface area. That means if you work out the area of the entire surface, you get 864. But if you let x be one of the sides of your cube, then this front area is x squared. In fact, all the sides will be x squared because it's a cube. Right? Now, how many faces? You call these faces. How many faces does a cube have? You got one in the front, one at the back, we can't see, that's 2. Then you got top and bottom, that's another 2, that's 4. And you got the left, the right, and the left, that's another 2. So there are 6 faces, no more than that. So each face is as area x squared. So therefore, altogether, the area will be 6x squared. but it's given that the surface area is 864. See? Then if you work out x squared is 144, so x is 12. So the side of the cube is 12. Now, what do they say here? They say the cube is cut into n identical smaller cubes, each with surface area 54. So you've got smaller cubes. We don't know what the side of the smaller cube is. Let's call it y. Let y be a side of the smaller cube. So what do we have? We have that surface area is 54. So for exactly the same reason, the surface area for this is 6y squared. It's 54. Y squared is equal to 9. So y equals 3. All right, so these smaller cubes now, like that, you put them together and they're cut into these. So how many smaller cubes are there? Like the smaller cube is 3 by 3 by 3 by 3, because we just saw that the side is 3 by 3. So you want to know how many there are altogether. So you really have to find out how many cubes. Now it's a problem on volumes, you see, because the volume of this small cube is 27, 3 by 3, and the volume of the large cube we saw that the side was 12, right? So therefore the volume there is 12 cubed. So we want to know how many of the small fits into the large one. So the answer will be how many 27s are there in 12 cubed? Let's leave the 27 as 3 cubed. So it will be the number of 27s in this large cube is, you can do long division, multiply 12 by 12 by 12, we get 1,728, and divide by 27, and after ages, you'll eventually get to the answer. But if you use fractions, this is just 12 over 3, all cubed, and 4 times 4 is 64. 4 times 4 times 4. See how quickly you can get to the answer instead of multiplying 12 by 12 by 12 and getting a big answer and then seeing how many 27s are there inside it. And you'll see the answer is 64. But if you do it like this, beautiful. Fractions are very powerful, okay? Because you can cancel them, obviously. This is 3 cubed times 4 cubed at the top. So 3 cubes cancel and you're left with 4 cubed. Okay, so that takes care of problem number 18. And just to check, yeah, okay. Oh, we did it exactly the same way. Yeah. So I didn't have any other ways of, didn't give you an alternate solution. So let's now get on to the next problem, which is this one. The diagram shows 3 squares. Find the total shaded area. Okay, you've got 3 squares side by side. They're all different sizes, but you know that this thing here is 3 units taller than that one, and the big Y is 8 units. It doesn't tell you whether they're centimeters or not, so you just say units. Could be anything. So this is 8 units more than the smallest square, and you want to find the total area. You have only You actually got three pieces of information: that length, and this whole thing. So let's just give a name to one of the cubes. Let's call this x, well, the squares. So the smallest square, let the side be x. Okay, so what does this mean? It means now this is 8 here, and here you got x. So the side of this large square is x plus 8. So let's put x plus 8 here. Okay, so this is also x plus 8 here, because that's a square. All the sides are equal to x plus 8. Okay, now in particular, this will be x plus 8 here. Okay, so if this entire side is x plus 8, and you have to remove 3 from that to get to the side of the last square. So this will have to be x plus 5, because x plus 5 plus 3 will give you x plus 8. So there you have it. So this distance here is x plus 5. That's the side of this square. So now we know the sides of all the three squares in terms of x. But you know that the bottom one, it adds up to 25. Right. So when you add the three sides, x plus 5, that side, plus the large side, plus the small side, you're going to land up with 25. And that's a very nice, simple equation, because you've got the three x's on one side. Here you got 5 plus 8 is 13. So it's 25 minus 13 is 12. 3x is 12. Right? Goes into it exactly. So x is 4. So they want to find the total shaded area. Now we know x is 4, you see. So this area here is 16, side squared. And we know x is 4. This whole thing here is 12 now, right? X is 4, 12. And that area will be 12 squared, which is 144. And here you got x plus 5. So remember, x is 4. So x plus 5 will be 9. So this is 9 squared, which is 81. That's the area. You're asked to find the total shaded area. So what I've done here is calculated the areas of each of those squares, and that can take me quickly to the total area. You just add up all these things. 81 plus 144 is 225. 225 plus 16 is 241. So that's the answer. So it's always nice to put down square units. In areas, you should put on the volumes will be in cubic units, so squares, areas in square units. You should put that down. Okay, so that takes us to question 19. And I think I'll just do one more. And I will continue the rest in another some other time. But let's just do this. You want to clear the drawings and just check to see. Oh, so yeah, I did it a little bit differently. And I get the same answer, 241. But I called this thing here x. But I in my calculation I called that x. They say let x be the side of the smallest square. And so we did this, right? And we saw this. If you use this as x, you have to draw a construction line, right? Which makes life a little bit complicated, but you will still get to the same answer. So you can have a look at that, see, or you can draw that red line and use that to calculate the total area, right, without looking at my answer. Okay, so that takes care of that problem. We need to go on to the next Problem number 20. Problem number 20 says that Neo, I've never heard of that name before, begins with a set of numbers from 1 to 10. All right, so he starts off with all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, oh, it's a she. I don't know what the Neo is short for. Probably is a Japanese name. After removing one of these numbers, so one of these numbers were removed, she places each of the other numbers into one of two sets. Also, she removes one, we don't know which one, and then she breaks it up into two sets. Maybe you got 1, 5, 6, maybe 9 was removed. And yeah, you can put 7 here also. So at this side, you got 2, 3, 4, 5, 6, 7 is there, 8, 9. So you break it up in two sets. Now the product of the numbers in one of these sets, when you multiply these numbers, is equal to the product of the numbers in the other set. So if the product is P here, P for product, then this product is the same. Okay, so in other words, when you multiply all the numbers together, you're going to get P squared. But remember, one number is removed. Oh, I removed a 9. Okay, so I should have a 9 there. Okay. Now, when you multiply these, you're supposed to get a square number. Right? So one of the numbers is removed, and the product of the other two is a square number. So if you look at this carefully, you'll see that 7 occurs all by itself. Suppose we multiply the whole thing out. Multiply all the numbers. And this is multiplying all the numbers except 1, whichever one was removed. But if you multiply all these numbers, then you're going to get, I'm going to write it and factorize it. You get 5,040, I think. Okay, so when you factorize this, you're going to get 2 cubed, 2 to the power of, I'm doing it mentally, and I can do it very quickly. Oh, wait a minute. 5,040, 2. No, it's 3628, 288, 00. Woo! That's the server. Okay. So let's do it like this. I'm going to multiply just those first 7. Now, I think all should know, it's always nice to know the first few factorials. And you've come across factorials before. So the first few factorials will be 1 factorial, 1 times 2 is 2 factorial, 1 times 2 times 3. It's 2, 6, 24, 120, 720, 5,040. So it's 7 factorial is 5,040. And here, 8 times 9 times 10 is 720. Okay. And when you factorize these into powers, now this thing here is 816 times 315. And this is 16 times 45. So now I can factorize 2 to the power of 8, 2 to the power of 4, another 2, yeah? 315, 9 goes into that, 9 goes into that also. Okay, I'm doing it rapidly. And then 5 goes into this, and there's only one 5 here, so it's 5 squared. And there's only one 7. Right. So you want this to be a perfect square when something is removed. The only thing you can remove is 7, you see, because it occurs by itself. So you can't leave 7 here, because otherwise it's not a perfect square. So you have to take, so the number that was removed was really 7 was removed. And what's left? You got 2 to the 8 times 3 to the 4 times 5 squared. And so if p squared is equal to this, then p will have to be 2 to the power of 4. Because if you square this, you get 2 to the 8, 2 to the 4 times 2 to the 4. And here it'll have to be 3 squared, right? Times 3 squared. And here you got 5 squared, which is 5 times 5. And if you multiply these things here, you get 16 times 5 is 80, and 80 times 9 is 720. Okay, so P is 720. They asked you which number did Neo remove. So we can see that 7 was removed. I could have stopped right there. But I'm saying that when you remove 7, I'm just checking to see that this number is a perfect square. And then you're left with 720 squared. Okay, so that takes care of problem number 20. And if I clear the drawings and go to the solution, okay, there too you got 720. So this is quite correct. All right.